Hello, my name is Konstantinos Gavril. I'm a teacher of physics, and the video you are watching is about the Kirchhoff's laws in the current circuit that you have on your screen represented. Okay, now let me remind you the Kirchhoff's laws, and we are going to see how they work in the circuit simulator Falstad. Okay, first of all, let's see what these two laws state. We have the current law of the Kirchhoff current law. We have I equals to here it is I. Let's say this is I1, here it is I2, and here is I3. Remember that we have that the incoming current is equal to the junction, to the node here. This is a node, okay. The incoming current in the junction equals to the sum of the currents that go out of this node, okay. Okay, this is something that we are going to see, to realize also in the circuit simulator that we are going to work. This is the current law of Kirchhoff's current law. Now let's see the voltage law of Kirchhoff. Now suppose that we have here a V1, and here, because we have the same uh, because we have a parallel way connected resistors, we have a V1.2. Okay, V2.3. Okay, I say that this is a V total between V2 and V3. It is the V2.3. Okay, here is the V of the source. And how do we work? We make a loop as we wish. Okay, this is the direction we are going to walk, let's say, across this circuit. So here I have a plus. Also, because the current is in this direction, also because it is entering from this part of the resistor, we have a plus, and here we have a plus also, and here we have a plus also, because the current enters from here. So totally we have a plus here to these two, three. Okay, so we are going to see that the voltage, the algebraic sum, remember, the algebraic sum of the voltage drops across the loop is equal to 0, which means that the V total is 0 across this circuit, across this, okay, circuit. Now, how are we going to express it? Vs, we are going, how, as we walk here, eh, as we walk, suppose that we walk here in a way, we walk here to the to this direction. What do I meet? I meet here a minus, as you can see. So I will apply a minus Vs, and as I walk also here to this direction, okay, I meet a plus. So I will use a plus V1. And as I continue walking through this, along this circuit, I meet again a plus V2, comma 3. And this is equal to 0. Okay, how can we write it also? Minus Vs equals to minus V1 minus V2. 2,3. Or in other way, okay, in other words, we are going to change all the signs everywhere, and we are going to get this one. Okay, so the V of the source, the voltage of the source is equal to the sum of the voltage drops across the resistors of the circuit. So this is what we are going to see in our circuit simulator. Let's go to the simulator. I'm going to draw this circuit right here. Draw. I will add my source from inputs. Add voltage source with two terminals. Let's make it like this. I'm going to draw also my wire. Be careful with the connections. Here and here. Add resistor. Add another wire. And I'm going to add two more resistors in a parallel way. I'm going to have this resistor here. I'm going to draw the wire right here. Okay. I will insert another resistor here. Okay. And I'm going to close my system here. Okay, I'm going to close here with a wire. Okay, draw, add wire, out here and around the circuit. I'm going to close it like that. And as you can see, we have a current flowing. Okay, now let's apply the proper values. The exercise says 9 volts, 1 kilo, 10 kilos, and 2.2 kilos. Let's do it. Double click on the source, 9 kilos here, 9 volts here, apply, and OK. We have 1 kilo here that it is ready. We have 10 and 2.2. 10 here, 10 here kilos, and 2.2 here, super, 2.2 kilos. Apply and finish. Now, we are going to see what does they do they ask from us. We have the PQR points. Where are these points? On the left of the R1, on the left of R2, and on the left of R3. So there we are going to use the ammeters. Okay, the ammeters. Here we have apply the value of the current, and the current. Okay, so we are going to apply in these points the ammeters. Let's do it. I'm going to choose draw and select in order to remove this cable and in the place and substitute it with an ammeter. I will choose an ammeter here. Ammeter. This is it. Okay. Now I am going to do what? I'm going to apply an ammeter on the left side of the 10 kilo ohms resistor. So I'm going to make it a little bit smaller. So I'm going to use the select tool. I'm going to choose here the and make it smaller in order to apply here my ammeter outputs. Ammeter ready here. Now we are going to apply here an ammeter also. Draw, select. I will make a little bit smaller my resistor, and I will apply there an ammeter. Whoops, outputs, ammeter. Here will be my ammeter because this is where they ask me to apply it. Now, we are going to check our prefixes. We see here that we have, what is a prefix? The prefixes is the milliamperes, microamperes, okay. You see here I have a milliampere option, here I have a microampere. I will make it milliampere, no problem. Scale, okay, I double click, cancel, double click in order to show you. Scale, milliamperes, apply, and okay, super. You see? Okay, now we are going to check our values here and see that I have current of 3.2, that it is equal to 0.579 plus 2.632. Okay, if we make this addition, we are going to get this value of the current. This is the current, the Kirchhoff's current law. Okay, now we are going to apply these values, okay, in our PDF file, and it is okay. We are going to apply it. I'm not going to apply it now, but this is what we are going to do here. It is very simple. Okay, now I'm going to use my voltmeters, draw, just a moment please. I'm going to draw my voltage, so outputs and labels. I'm going to choose my voltmeter. Okay, I'm going to bring 1, 2, 3 voltmeters. Okay, and afterwards I'm going to apply them inside my drag and select. I will apply one here outside, another one here, and another one over here. And I will make it a little bit smaller. Okay, I could do the circuit larger, but okay. I'm going to insert now, add wire, my wires. Be careful, choop here and here to the right connection points. Here also to the right connection points. You see when okay, to the right connection points here and here. Now it is ready. We have all our values. Okay, and as we can see, I will write the other law of, okay, here we have a 9 voltage incoming um, from the source, 9 voltage, and I have here 3.211 plus, as you can see, 5.789. If we make this addition, we are going to get 9. Okay, so this is the law of Kirchhoff, the Kirchhoff's voltage law. Okay, so this was the two laws of Kirchhoff. These were the two laws of Kirchhoff, and some, uh, and we have arrived to the end of this video.